So this lesson is about how to do various analytical tests. The first one is about how to do the descriptive analysis for a continuous variable. Okay, for a continuous variable. So you need to go to analyze. As you can see, my cursor is at the analyze point. You click on it, and then you get a menu that goes downwards. So on this menu, you select, you come to the descriptive statistics, and then go to frequencies. Okay, run frequencies. So this is the first option. You go to frequencies, and for instance, we want to just do the, for instance, the number of trimesters. Okay, it's a continuous variable. Let's just do the height. Then we do okay. You come to statistics. Since they're continuous variable, you do the measures of central tendency. You can select the minimum and maximum, the variance, the range, the standard deviation, and you can do the percentiles. Okay. Once select the quartiles, because the percentiles deactivates the continue button, so you can select the quartiles and then just say okay. Once you're done with that, we have the option of making a chart. So if you come to charts, it gives you various options for charts. You can do a bar graph. Now remember, this is continuous variable, so you can't use a bar graph. You can't use a pie chart, but you can do a histogram because it's a continuous variable with its normal curve. Okay, then you say continue. For the format section, don't do anything, just say continue. Style, there's nothing to do there. Just continue. Bootstrap, don't do anything there. So you can display the frequency table, but in our instance, we just want the statistics because these are continuous variable. So deactivate the frequency tables. Just say okay. And as you can see, the data generates the measures of central tendency and measures of dispersion as indicated for our value on height in meters. Then we have our histogram with a normal distribution curve being shown. Okay, so that is how we do for a continuous variable. Now we can go to our data again. We want now to do for a categorical variable. So we go again to analyze, descriptives, frequencies. Now remove the continuous variable. Let's get our categorical variable. Now a categorical variable in this instance, we can take gender, which is sex. Say, we take it there. Come to statistics. Remember, this is a categorical variable, so we don't need measures of central tendency. Don't need the measures of dispersion. Remove them. Say continue. Now here we can do a chart. We don't need a histogram because our data is categorical. We can do a pie chart. Now we can also tell it to do percentages because it's easier to make interpretation out of the percentages. Okay. Then say okay. For the format, you do nothing about it. The rest, just leave them as they are. Now with this, we need the frequency tables. So we click on this and allow our work to be done. So we have our frequency table here. Okay. And it has used our valid values. Okay. To present. So there seems to be a mistake in our data set. There is a 3. So I'll need to go back there and search for that 3 and replace it with a 2. Okay. So I will redo the analysis so that I go back the same way, say okay, so that our table now shows much better because we are dealing with 2 values. Okay, so remember again, I said we focus on, okay, you are to focus on the use of the valid percentage in making your graphs. So if you look at this graph on SPSS, it doesn't look very neat, very nice, like the graphs that we make. It doesn't have a title. It cannot tell you the proportions for each. So that is why we prefer the use of the Excel made graphs, okay? So we prefer the use of the Excel made graphs. So in the Excel, we recommend that you can take that data. Yeah, so like our output here, we had our, so you can just copy the entire. Let's copy it as a plain text. And then we take it to our Excel. So we open our Excel and we paste it. Okay, it carried the text only. So let me copy it as an Excel worksheet. I take it to my Excel. I know it is showing on your screens that I've gone to Excel. So I'll share the screen again, but now from the Excel point. So we have our two values here, which I will open another screen, another sheet, sorry. Then we had, I think, male was our first value. Male. Then we have the female. Okay, now remember here we are supposed to have it as so we are supposed to have it as a you're supposed to have it as a percentage. So I will try to type the values as percentages. So let me first remove them from here, cut and paste them here. Then I want them as percentage. So I will type in 42.9 and 57.1. Okay. Then I just highlight them as we always do for making of graphs in Excel. And I come and make my pie chart. Okay. Make sure that you select what you like. Okay, I like that one, which gives me the details of, okay, so this looks much better and suitable for the eyes. Put your title, gender distribution of nursing students in biostat class in November 2022. Okay, so you have your title there and the graph is done. Okay, so that is how we do it on Excel. We transfer that just to show you how to transfer your data for the frequency and then go and draw it in Excel. Okay, so now we go back to our SPSS data and we proceed with doing the analysis. So we have done analysis for a continuous variable and analysis for a categorical variable. We even proceeded to draw a graph. Now we start on relationships, okay? Now, here we are dealing with students and we like to see if there's a difference in for instance, the mean GPA score with the standard GPA score of 3. So our students passing, okay? So we compare means, that is a t-test. We go to compare means. We select one sample, t-test. You pick that value that you want to test, okay? And in our case, we want to, maybe let me use the age. age. And the normal age for university students could, let's say it is 22, because they'll come maybe at around 18, 19, 20, up to 24. So 22, let's say 20, the average age of 20. Want to see if this class has those average age of 20. So you enter the test value of 20 down here. Okay. Maybe let me do the one for blood pressure. We had a blood pressure value here for systolic, as we did it in class. So let's do this one for systolic, which is always 120. Now for the options, just leave it the way it is, nothing else to do, just to add that value and you say, okay. And this will be the output for our one sample t-test, gives us the mean for this population. And our significance, it gives us a t-value, the degrees of freedom. Remember, we talked about that, which is usually n-1. We have a sample of 35, and that gives us 34. And we have our significance value, which is our p-value, which is indicated here. Okay, so in this p-value, we are able to use it to represent our work and say that there is a big difference. Okay, there's a statistical significant difference between the mean, the standard mean in the population of 120, okay, and the population mean in our sample of 134. Okay, that is now about one sample test. So you can play around with the various continuous variables, knowing what is the standard mean value in the population and see whether it is different. Okay, so you can do also from, we can do the shoe size, compare means, one sample t-test. Okay, maybe let's do for diastolic. Okay, I need to change that data set first. It is in categorical mode, so I need to change it to scale so that as it analyzes, it makes it more correct. Okay, so now I can proceed, do analyze, compare means, one sample t-test. We are doing diastolic, and we know the average is 80 in a population, and we say, okay. So in this case, we see our p-value is less than 0.05 at 0.036, and our mean is 84, which is slightly higher from the population mean. So, and we say that there's a statistical significant difference between the population mean of 80 of diastolic to the mean in our population of 84. Okay, so you assume that you had your hypothesis, then we say that we reject the null hypothesis and accept the alternative hypothesis that there is a significant difference between the population mean of 80 for diastolic to that in our population. So that's about the one sample test. Now, if you're comparing, let's say, the diastolic blood pressure between the males and the females in our study, we go to analyze again. Compare means, now we're comparing two independent groups, that is males and females. So you compare the two males and female groups. So you go to the independent samples, t-test. So here we bring in our test variable that we are testing is the, let's say, systolic blood pressure, and our grouping variable becomes our gender, which has two options. And so you need to know how was that data entered. So if you hadn't entered the data like now, it's good to come and check and find out how that data was entered. So here we can see it was as 1 and 2. So we go back to our data, our analysis window. Okay, we define as 1 is 1 and 2 is 2. Okay, sometimes if the data was entered 0 and 1, sometimes you can enter 2 and 3. Yeah, so you enter group 1 will be what, and group 2 is which value. So once you're done with this, here you do nothing. The next one you do nothing. You just come and say, okay, and there is our output. Okay, So you can see the males have a higher blood pressure than the females of 146. And when we come to our p-value, this was an F test. So our t-test is here. So the value that we read, because these are t-tests, we don't read the F, okay, value. We read the t value, the t degrees of freedom, and then this value. So this is the value that we read. The significance, which is two-tailed, the upper value, which is 0.002, which means that there's a significant, statistical significant difference between the mean systolic blood pressure of the males vis-a-vis the one of females of around 20, 22, okay? Yes, so that is what we do. We can also get another one, another example. We can do the diastolic. Let's try the diastolic, okay, with the same group. Just say okay. And so also the diastolic, we can see there's also another significant difference. The males have a higher than the females who have it at 79 or 80. Again, the p-value is 0.002. Okay, so that's about comparing two different groups. Okay, now if you have three different groups, we can compare the systolic among three groups. So we do the one-way ANOVA. Okay, so we are comparing, and with the year of study, for instance, has more than three groups, and then we are comparing the systolic blood pressure. Okay, so again, you don't need to do anything much. We just continue, come to postdoc, just continue, nothing much. Options, we can allow some descriptives to be done so that we get an output. So just do the descriptives for the options. Bootstrap, just leave it alone and then come to okay. So the descriptive enables us to see those, because we don't do the descriptive, we just get this output alone. So when we look at this, looking at the mean for the various years, we have 3 years that were here. We didn't have first years in this class, and this biostatistics class, so we didn't have any first years in this class. So the p-value is 0.315, which is greater than 0.05, which means there's no significant difference in the mean systolic blood pressure among the various years of study. So even though you see there are some 138, 144, 129, statistically, according to the statistical analysis, there seems to be no difference in the mean or occurrence of this among the various groups. So that is for when you have 3 or more groups. Let's do another one for one way. We can do for the systolic. We see whether it was different among the various years of study. Okay. Now for the diastolic, we can see again it's not statistically significant, and the mean values are given there. And so this is how we read. Now then we have the paired samples t-test. We say this is when you take a sample that has been measured twice, but the same people have been measured at different times. So in our data set, we have the systolic blood pressure before and systolic blood pressure after. Okay, so we have the first variable and the second variable, and we are to get those values for each. So once you're done, you just need to say okay, and it will do for us the paired samples t-test. So with us, we have it there. The before, the mean is 186, and after it's 167. So when we look at it, our p-value is very statistically significant. It is at 0.00, that's less than 0.05, which means there's a very statistical big difference between the systolic blood pressure before and after. Okay, so maybe the drugs that were given lowered that systolic blood pressure. Okay, so that's how we do a paired samples t-test of the same population, measures taken at different times. Now, so that enables us to finish about the t-tests, okay? Now we want to do a correlation when you are comparing two continuous variables, okay? So we have, you go to descriptive statistics, you come to crosstabs. Descriptive statistics, crosstabs. So here, let's say we want to compare the weight, yeah, and systolic blood pressure, let's say, okay? So weight and systolic. And let's compare the shoe size. That's what we did with the GPS score, for instance, okay? So remember here, we need to go, that there you do nothing. Statistics, we are doing correlations because we are dealing with two continuous variables, and you just leave it that way. You say continue, you come to cells. We don't need to do anything, just remove the observed. Oh, it needs the observed so that it can continue. Just, it comes already ticked. Then format, just leave it the way it is. Style and book stuff, just leave them the way they are. And just say okay. And it will automatically do for you the cross tabulations. And so we have, remember our sample is greater than 30. So we read the Pearson's correlation, which is here, the Pearson's R, and our significance, okay, value is 0.000. Okay. Now, when you read this, you are able now to have you are able to tell the value that you are getting here. So the other way to do it again is you come analyze and correlate and use bivariate. You're doing two values. So we were doing the shoe size vis-a-vis the GPA score. That's what we did. Okay. So remember our sample is big. So here it allows you to select. Okay. So you can select just the Pearson's and the two-tailed. Remember, two-tailed is better. Always select the two-tailed. Okay. So just say okay, and it will generate. So always use the correlate, analyze, correlate for correlation. Always for analyze, correlate, always go analyze, correlate, and then bivariate when you're using two options. So this one is more clearer because it gives you the significance value, which is 0.999, which means there is no relationship between the shoe size and then we have our correlation R, which is at 0.00. So it does mean that there is no correlation between the GPS score and the shoe size. Okay. So maybe let's do one more and do again correlate bivariate. Let's correlate the age and the blood pressure. Okay. Say okay. So if we look at this one, our R is negative 0.166. It's a very, very weak negative. And the p-value is 0.346, which means that it is not significantly or statistically significantly related, age and the systolic blood pressure. Okay. So you can also play with any of those values and see what happens to any of those values that we have. That is for correlation. So for correlation, I've advised go for analyze, correlate, bivariate. Analyze, correlate, bivariate. Then we have the last one, which is when we are dealing with categorical variables. Categorical variables. So for categorical variables, two that you are relating, you come to analyze, the statistics, go to cross tabs. Okay, now we go to crosstabs. Let's correlate the gender and let's say the blood group of the individuals. So these are two categorical variables. The statistics, remember to go to statistics, remove the correlations. Now we are using the chi-square because they are two categorical variables. You say continue. Now for the cells, we can give the percentages, the columns, okay, what has been observed, and you say okay and proceed. So we have this table with the various values, and then we have our p-values here. We read this Pearson's value of 0.701, which means there is no significant relationship between the gender and the blood group distribution. Okay. We can do another one, descriptive statistics, crosstabs. Okay. We can do maybe the gender and which born people are in the family. Okay. Just say okay. And we can see that there's no relationship, again, 0.176, the p-value, between the gender and which born somebody is in the family. That's first born, second, third, fourth, yeah, who had, which born somebody had in the family. So you can always play with any value as long as it makes sense, it follows the rules. What type of data is it? Categorical, qualitative, quantitative, yeah, and how it relates to the other variables. Okay, so now we will do for, yeah, so those are the various analytical measures we needed to do. And I believe that now they are clear. So the non-parametric tests are down here, and we use them for the sample. One sample test, if our sample is less than 30, independent sample test for if the sample is less than 30, and then related samples, which is the equivalent of the paired samples t-test for samples that are less than 30. Then we have the survival test. You remember we talked about the Cox regression for survival testing when we are doing survival analysis. So these ones, you'll also appreciate them during your master's and your PhD. So for now, we just need to do how to do simple, okay, analysis for our data, the descriptives, the frequencies, correlations, chi-square test, the t-test, and the ANOVA for now. So we also have the regression analysis. We have the multinomial logistic, we have the binary logistic, which we talked about. They are here. You can always do them when need arises. So I believe with this, you are able to appreciate and can be able to follow up and do your analysis as need arises. So I just maybe emphasize maybe another way to do descriptives is here. You come to descriptive statistics, descriptives, and you can always take your variable of interest, like we did for height, do selection here. Although here it doesn't allow you, you can only do the mean here, variance and the range. The other one gives you better options for this, both the measures of central tendency and the measures of dispersion. So this is another way where you can get, again, the same values, yes, if you always want to use another way, but always the other one is better for you. So you can see the values have been given here and indicated for us. Yeah, so with that, I believe that now it is clear for everyone. You can always replay the video and be able to appreciate how to carry out various tests, various graphs within the SPSS. Thank you, and enjoy. In case of any question, you're free to ask on the chat or WhatsApp. You are free to email. You can call for any clarification. Okay, bye. Thank you.